Hey guys, how are you today?
We're fine, thanks, and you, ma'am.
Okay, thank you. I wasn't aware that you guys joined. Uh, Okay, we're gonna do corrections. I don't know if you still have um this piece of work. I don't know if you have the screenshots with you. Do I need to share this or are you okay without it? Guys, do you still have these questions or do I need to share them with you? Guys, are you still there? Are you able to hear me?
Yes,
Yes,
ma'am, we
ma'am.
can hear you.
Okay. Do you still have these questions or not?
Ma'am, I don't.
Okay. Fine. I'll just assume that both of you have them. I'm just gonna move this up. Okay, so the first one, okay, I'll just remove it when I'm writing it. Okay, the first question was question one, and the statement went like a bag contains 7 yellow balls and 5 red balls, right? And then they said one ball is taken from the bag at random and is not replaced. Okay. One ball is taken from the bag at random uh, and it is not replaced. Okay. And they say a second ball is then taken from the bag. A second ball is then taken from the thingy. And they say that determine the probability that both balls are red. So I told you guys before you answer this type of questions or this type of question, you have to um, draw a tree diagram to make your life easier. Okay. It's not a must. If they don't say draw it, you don't have to draw it. But when you draw it, you'll be doing it for yourself. You'll sort of be like reducing the thinking time because if you draw it and then you label everything accordingly, when they ask you each and every question, you're gonna be able to uh, grab a answer from that tree diagram um from that statement that you're given. Do you guys get me?
Yes, ma'am.
Okay. So now the first thing that we're gonna do, we're gonna draw a tree diagram. Okay. They said the one ball is taken out. Okay, let me do this. One ball is taken out, and then a second ball. So there's a first and the second. So that means it's how many colors? It's two colors. Okay. So that means we're going to have something like this. We're going to have this, which is going to be yellow and red. It's two colors. And then how many chances or how many times do they take the balls out of the bag? First and second, one and second. So it's going to be two times. So this right here represent the first one, the Y in red. The first branch represent the first thingy, first ball being taken out, and then this is going to be the second time a ball is taken out of the bag, and then you're going to have yellow and red and then you're going to have yellow and red. Okay, now you have to label them because not all the balls are equal in the bag. Okay, you have seven you have 7 yellow balls, and then you have 5 red. So you see they're not equal. So you have to state, even when they're equal, you have to state the probability. Ne? So the probability at first for this one, okay, um, the probability for this first one is going to be 5. No, it's not going to be 5, but it's going to be, wait, it's going to, oh no, it's going to be 7 yellow. So it's going to be 7, and then you're going to say 7 plus 5. When you add the 2, it's going to be 12. Yeah, it's going to be 12, and then you have 5 reds, so it's going to be 5 out of 12. Okay, so all of these represent what? They represent the total numbers in the bag, ne? Given that no ball has been taken out. Okay, and then the second one, okay, we're going to focus on this one. Given that the first ball that you take from the bag is yellow, remember, there's no replacement, ne? There's no ball that is going to be replaced. So if you take a yellow bag, okay, the last time I drew something like this, and then I said you have what? Let's do this. We have 1, 2, 3, 4, 5, 6, 7. Okay, and then we also have red. Okay, 5 red. 1, 2, 3, 4, 5. Okay, so in total there are 12. Okay, so this is a bag containing 12 balls, 7 yellow and and what, and 5 red. Okay, so now given that you take one ball out of this bag and that color of the ball is yellow, let's do this. And then now this is going to what happened. So you're going to count how many are left. If one yellow is taken out, how many yellows are you going to be left with? Guys, how many yellows are we going to be left with if the first ball was yellow? The first ball was yellow and it was not replaced. How many yellow balls are we going to be left with?
Ma'am, is it going to be 6?
It's going to be 6. Did you say 6?
Yes, ma'am.
6, okay. 6 out of how many balls?
12.
12. Are they 12?
In total,
If you have 12 balls in a bag and then you take one out, how many balls are you going to be left with?
11, ma'am.
Yes, so it's going to be 11. There's no replacement. So if there's no replacement, that means the number of balls is going to decrease. Now, if you take one ball out, that means you're going to be left with one or less than one, or one less. Okay. Now, how many reds are we going to have if the first ball was yellow? If the first ball to be taken out, how many how many reds are we going to be left with?
5.
5. So it doesn't change because we didn't take out a yellow ball. We took the ball that was selected was yellow, so it's going to be 5 over 11. So this one does not get affected, other than the denominator changing, because now you have a total of 11 balls instead of 12 balls. Okay, now let's go to the second one. Okay, given that the first ball to be taken out or the first ball to be selected is red, how many yellows are we going to be left with?
7.
7. What will be the total number of balls? 7 out of
11.
Yes, 7 out of 11. Remember, the statement is still the same. The one ball is selected at random, and it is not, and then the second one is taken, and it is not replaced. So if it's not replaced, the total will now change. So, how many reds are we going to be left with, given that the first ball to be selected was red?
4.
4 out of 11. Okay. Now, okay. Another thing that you can do, you can multiply yellow and yellow, which is 7 over 12 with this, and then you have the probability of yellow and yellow. It's going to be 7 over 12, multiply it by what? By 6 over 11, okay? And then for this one, you're going to say 7 over 12. This will be the probability of yellow, picking a yellow, and then a red. It's going to be 7 over 12 multiplied by 5 over 11. Then it's going to be, I don't know, how much are you guys getting? 7 over 12 multiplied by 5 over 11. Okay, and for this one is going to be 5 over 12 multiplied by 7 over 11. And then for this one, red, going to be 5 over 12, 5 over 12, multiply it by 4 over 11. Now, how much are you getting for all of these? How much are you guys getting? Guys, are you calculating?
Yes, ma'am. Ma'am, I got some answers.
You got what?
I've got some answers.
Okay, how much did you get for the first one?
7 out of 22. And then for the second one, I got 7 over 22. And then for the second one, I got 35 over 132. And then for the third one, I got 35 over 132. And for the last one, I got 5 over 33.
5 out of 33. Let me wipe these. Okay. Okay, for the third one, you said you got 35 out of what?
Out of 132.
According here, the last part, you said 35 over 100 and
132, ma'am.
132. Okay. 132. And then this one, you said how much did you get for 5 over 12 multiplied by 4 over 11?
I got 5 over 33.
Okay. Okay. 5 out of 33.
Yes, ma'am.
Okay, cool. And let's see. Okay. Okay, cool. Now that you got all of these, let's go to the questions. Now they're asking you the probability that determine the probability that both balls are red. Which one is representing red and red here? Is it the first one, is it the second one, third one, or the fourth one?
It's the fourth one.
The fourth one, that's correct. And what is the fourth one?
5 over 33.
5 over 33. 5 over 33. And this is it. Okay. When you are multiplying these things, ma'am, just do them separately. Just say 4 over no, excuse me, 4 multiplied by 5 or 5 multiplied by 4, and then you write it, and then 11 multiplied by 12, and then that is going to be your denominator name. And the reason why you don't or you're not encouraged to simplify name the final answer is the fact that when you add everything together, remember when you add everything here, when you add everything here, they must equate to 1, né? So if you already simplified them, it's going to be a long route when you try to add them together, okay? So here it's going to be 20. Okay, I'm going to write this. Did you get that 0? So it's 20 divided by 132, né? And then here it's, what is 7 multiplied by 6? What is 7 multiplied by 6?
42, ma'am.
42. 36. Yes, it's 42. Yes, so it's 42. So now your answer for the first one is going to be define the first answer or the first yeah, it's going to be 20 divided by 132. And then you are done just like that. And then the second one says, the which is B, they say determine the probability that both balls are of the same color, or both balls are the same color. Same color, that means it's going to be yellow and red and red. Selecting yellow and then selecting yellow again, or selecting red and red again. So what you're going to do here, you're going to add the probability that you got for yellow and yellow, add for red and red. So number 2, the answer is going to be 42. Oh no. It's going to be 42. Okay. It's going to be 42 over 132 plus 20. Wait, is it 20? Yes, plus 20. Yes, 20 divided by 132. Okay, and then you're going to get your answer. Do you guys get it?
Yes, ma'am.
Do you see how easy it is when you have a tree diagram, even though they didn't tell you anything about it? You see how easier it is, or how nice it is to answer these questions when you have your tree diagram. Okay, now the answer is 62 over 132. So if you want to simplify the 62 divided by 132, this is where you do it, but you have to show the 62 over there, and then you can simplify it. Maybe you when you press your 62 over 132, whatever that you get on your calculator, you may write it here. Even here, if you have 20 divided by 132, I think you said, what did she say? Gosh, I forgot. What over 33? Whatever divided by 33. So this is the way you can show it. You must show how you got to that 5 over 33 here. Just remembered. Okay. Now we're going to do number 3, which is that C there. They say determine the probability that the balls are different colors. The balls are different colors. Now, what is going to be, what are we going to do here? How are we going to answer this question? The balls are different colors. How do we answer this? Guys, how are we going to answer this one? What do they mean when they say the balls are of different colors? The probability, what is the probability when you're looking at this tree diagram? What are we going to do? How are we going to answer this? Guys, are you still there?
Yes, ma'am.
Don't you know how to answer this question?
No, ma'am.
Okay, fine. When they say the probability of the probability that the balls are of different colors. So when they say different colors, they simply mean that the probability of getting a yellow and then a red, or a red and then a yellow, ne? Because not the same colors, that means it must be yellow and red, or red and yellow, okay? So if you look at this tree diagram here, you have yellow and yellow, yellow and red, red and yellow, and red and red. Okay, so that means you're going to take the probability of yellow and red, you add it with the red and yellow, which is the first one for yellow and red. It was that one, yeah, 7/12 multiplied by 11, 5/11. And then you're going to add it with what? You're going to add it with the probability, yeah, red and yellow, which is going to be 5/12 multiplied by 7/11. We already got the answer, which was 35 divided by 132. So you're going to add those two together. You're going to have 35 divided by 132 plus 35 over 132. And then you're going to get 35 and 35, it's 70. So it's going to be 70 divided by 132. Do you guys get it?
Yes, ma'am.
Uh, 35, then it's going to be 70 over 132. And then if you would like to simplify it, we can simplify it. Yeah. Okay. Zira, did you get it? Do you have any question?
I understand, ma'am.
Okay. Okay, and then the last one out of these, they say at least one ball is yellow. At least one ball is yellow. Now you're going to go to the tree diagram, and then you look at we have yellow and yellow, yellow and red, red and yellow, red and red. Now I'm gonna ask you a question. Lihumo, do you have at least one yellow here?
Yes, ma'am.
Yes. Do we have at least one yellow here?
Yes, ma'am.
Yes.
Okay. Do we have at least one yellow ball here?
Yes, ma'am.
Okay, all right. All right. Do we have at least one yellow ball here?
No, ma'am.
No, ne? So that means what we're gonna do here, we're going to add the probability yellow and yellow, and with the probability yellow and red, and lastly we're gonna add this one. So we're going to add everything together. That has a tick. Okay, so we're going to have 42 divided by 132 plus 35 over 132 plus 35 over 132. Now this is going to be our answer. And then we're going to have, how much is it? What is 42 plus 70? Is it 112? 70 plus
Ma'am?
40. Is it 112? 70
Yes, ma'am.
plus 42. Okay.
Yes, ma'am.
112 divided by 132. And then if you like to simplify, this is where you simplify your 112 divided by 132. And then this is going to be your answer. Now, do you have any question? Do you correct, or did you make mistakes somewhere? Remember you wrote on Tuesday last time. Do you see your mistakes, or did you get them correct?
I saw my mistakes, ma'am.
Okay. All right. I'll just assume that there is no question, so I'm gonna hop on number 2. So number 2 says there are 4 boys and 5 girls who are hoping to be selected for a school quiz team. Okay. And 2 of them are selected at random to be in the team. Now, okay. Now, this also is going to need us to do a tree diagram. Ne? Remember, we're going to do a tree diagram to make our life easier, okay? So I'm just going to try and wipe these, and I'm just going to wipe these, and then we have, okay, let's try, okay. Okay. Gonna bring this back, and then now we're gonna have a tree diagram like this. Okay. All right. Now, what are we going to write here? What are we going to write here?
Boy and girl, ma'am.
Boy and girl, that's correct. Boy and girl. Okay. Okay, and let's see. Now they will take two of them, ne? So if they take two of them, that means we're still going to have another branch. We're going to have another branch here, which is going to be boy and girl. Boy and girl, okay? And if maybe they said they take in three, this is what was gonna happen. Ne? This was what's gonna happen. So it's going to be BG, BG, and BG, BG. Then if there were four, you were going to do this, ne? Depending on the number of the kids or number of the uh, learners that are going to be selected. So because now there's only going to be selected, they will only be selecting two kids or two learners. So we're just going to add our tree diagram here. Next, guys. Okay. All right. They said there are four boys and five girls who are hoping to be selected for a school quiz team. Two of them are selected at random to be in the team. Okay, cool. So now what am I going to write here and what am I going to write here?
Ma'am, for boys, you're going to write 4/9.
4/9. No, not 5. 4/9. I'm just gonna wipe these. Okay. 4/9. 4 for boys and divided by the total number of learners who are hoping to be selected. So it's going to be 4 divided by 4 plus 5, which is 9. And then here I assume that you're going to say 5/9, right?
Yes, ma'am.
Okay, cool. And now we're gonna focus on the second learner to be selected. If the first learner that was selected was a boy, what are the chances of selecting a boy? If the first one was a boy, what is going to be the chance of you picking a boy, of a boy being picked or selected? Lihumo, what would be the chance?
Ma'am, please repeat your question, ma'am.
What am I going to write here?
Ma'am, I've got an answer.
Okay.
Ma'am, I think it's going to be 2/9.
Okay, 2/9, and why?
Because if you times 4/9 by a half, then it will give it to you 2/9.
And why are we multiplying with a half, Zira?
Because we're dividing the boys into 2 sections.
Okay. I'll just get back to you. Luhumo, do you have anything to say?
No, ma'am.
Okay. You don't understand this part? Okay. Guys, this is what you're gonna do, ne? They say there are 4 boys and 5 girls, ne? So I'm just gonna draw these. Okay, let me just go sighting, and let me just wipe these. We have 4 boys and 5 girls, okay? So this is what you're gonna do. This is the learners who are hoping to be selected. You have a boy, 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 and boy, okay? And let's see. Let me use black for girls. So it's going to be girl, 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 girl. Okay. So this is what you can do to make things easier as well. Okay. So these are the total 2, 4. No, shorter one girl. It's 5 girls, so it's going to be last girl here. So this is what you're gonna do now, to interpret this thing to yourself. So you have a total of 2, 4, 6, 8, 9. You have total of 9 learners who are hoping to be selected for a school quiz team, which is going to be 4 boys and 5 girls. Now, if we take out, or if the first learner to be selected will be a boy, this is what's gonna happen. Zira, this is what you do. So in order for you to get what you're going to write here, here, and here, this is what you're going to do. So you're going to go to these, and then you check if the first one that was selected, is a boy. So that means minus 1 boy here. And now you're going to ask yourself now, how many boys are we left with in this cycle that are hoping to be? How many?
3, ma'am.
3, ne? 3 out of how many learners who are hoping to be selected? What is the total number of the learners who are hoping to be selected now?
8, ma'am.
8. Okay, 8. Okay, and now where's my thing? Okay. Okay, now how many girls are hoping to be selected now that a boy is selected?
5/8, ma'am.
5/8. Okay. Now let's look at the second branch. Now, given that the first one to be selected is a girl, now what are the chances of a boy being selected if a girl is the first one to be selected?
There's going to be 4
How many?
boys.
There's going to be 4 boys, ne? And okay. It's going to be 4 out of 8, right? And then how many girls are we going to be left with?
4 girls.
4. So it's going to be 4 divided by 8. And then now you have what? You have boy, we have boy, girl, and then we have girl, boy, and then we have girl, ne? Now if you want to know this is if you want to know the probability of a boy and a boy, this is what you're going to do. You're going to say 4 over 9 multiplied by 3 over 8. And then here you're going to say 4 over 9 multiplied by 5 over 8. Ne? And then if you want to know for girl and boy, you're going to say 5 over 9 multiplied by 4 over 8, right? And then if you want to know for the probability of a girl and a girl, of selecting a girl and a girl, you're going to say 5 over 9 multiplied by 4 over 8. 4 over 8, just like that. So it's 5 over 9, 4 over 9, 4 over 8, and 9 and 5 over 8, 4 over 9 multiplied by 3 over 8. Okay, and how much are we getting? How much are we getting here? 4 multiplied by 3 is going to 4, 8, 12. It's going to be 12. And then what is 9 times 8? 9 times 9 is 1. 81 minus 9. It's 72. What is 9 multiplied by that? Is it 72?
Ma'am, it's equal to 1/6.
Is equals to
1/6.
9 multiplied by 8. Yeah, it's 72, guys. So it's 72. And 4 multiplied by 5 is 20 divided by 72. Let me try to wipe this before I make a mess. Okay, over 72, and then we have 20 divided by 72, and then we have 20 again divided by 72, right? Okay, now that we got everything, now we go to the questions. They say determine the probability that 2 boys are chosen. Determine the probability that 2 boys are chosen. And then you're going to look at the tree diagram. Do we have 2 boys being chosen here?
Yes.
Yes. Do you have 2 boys being chosen here?
No, ma'am.
No. Do you have 2 boys being
No.
chosen here? No. Do you have 2 boys being chosen here?
No.
No. So that means the answer for this one is going to be just this one. We're not going to add it with anything because it's only one. There's only one, which is 12 over 72. So the answer for A is going to be 12 divided by 72. And in case you want to simplify it, this is where you're going to simplify it. Whatever that you have, it's going to be that. And then B says, determine the probability that at least one girl is chosen. Determine the probability that at least one girl is chosen. Okay, now do you have at least one girl here?
No, ma'am.
No. Do you have at least one girl here?
Yes.
Do we have at least one girl being chosen here?
Yes.
Do we have, yes? Do you have at least one girl being chosen there?
Yes.
Yes. So now because you have three of those options, or you have three of those probability, you're going to add the three probability. You're going to add BG, GB, and GG, which is what? Which is 12. No, there's no 12, but it's 20 divided by 72 plus 20 divided by 72 plus 20 divided by 72. And then you're going to get your answer. Guys, are you getting this? Do you have any question? Are you following, guys?
Yes, ma'am.
Yes, ma'am.
So we're going to have 60 divided by 72, and in case you want to simplify it, this is where you're going to simplify, right? And then our C says determine the probability that one girl and one boy are chosen. So when they say one girl and one boy are chosen, they don't anything that has to do with one girl and one boy, they don't necessarily mean the first one to be picked is a girl and the second one is a boy, right? So there's a situation where they say what are the probability that the first one is a girl and the second one is a boy. That's a different thing, okay? But here they just say a girl and a boy are chosen. So you're going to look at the tree diagram. Do you have a girl and a boy being chosen here?
No.
No. Do we have a girl and a boy being chosen there? Do we have a girl and a boy?
Yes.
Yes, ma'am.
Yes. Do we have a girl and a boy here?
Yes, ma'am.
Mm-hmm. Do you have a girl and a boy here?
No, ma'am.
No. So only two, ne? Which is 20 divided by 72 and 20 divided by 72. So it's going to be 20 divided by 72 plus 20 divided by 72. And then you're going to get 40 divided by 72. And then if you can simplify it, this is where you simplify it, okay? And there's no other question here. Okay, cool. Do we have any question? Anyone who doesn't understand anything before I enter this lesson?
I don't have any questions, ma'am.
You don't have any questions. Okay, do you fully understand or do you partially understand?
I fully understand.
Lihumo, what about you?
Partially.
Okay, cool. No problem. Let's see. Dun, 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 dun. Mm. Okay, cool. It's okay. It's okay. I guess we'll just do something on Thursday. Okay, cool, guys. Just try to get questions like this. If you don't have questions, I mean, if you don't have these questions in your books or anything, you can text me and ask me for a question. So if you do these things more often, then you're going to understand them better. Because if you do something over and over again, there's more chances of you understanding it even better. Okay, guys, I'll see you guys next time. Have yourself a great evening. Okay,
Bye,
bye.
ma'am.